Hello everyone, we are the Deep Blue AI team from Deep Blue Technology. We are fortunate enough to have achieved the second place in the VizWiz VQA Task 1 and the first place in Task 2. We are honored to share our methods in this presentation. Our team has 2 members in total. Team leader Jipeng Luo and member Jiahui Wang. As shown in the left figure, the data for this task consists of photos taken by people with visual impairments and the questions they want to ask. Each image question pair is labeled with 10 answers from the public. The training set consists of 20,523 image question pairs. The validation set consists of 4,319 pairs, and the test set consists of 8,000 pairs. These data points are also categorized into different types, including unanswerable, number, yes or no, and other, with varying frequencies of occurrence. The competition consists of 2 tasks. The first task is to generate answers based on the given image and question, and the evaluation metric for this task is average accuracy. The second task is to predict answerability of image question pairs. And the evaluation metric for this task is average precision. After an extensive survey on multi-modal papers and comparisons, we chose BIP2, bootstrapping language image pre-training with frozen image encoders and large language models as our base model for fine-tuning. The figure shows the pre-training process of the second stage of the model, which is the part we need to fine-tune. The GPU we used for training was V100. However, the whole model cannot fit into 32 GB GPU memory. We then tried to split the model to multiple devices using Hugging Face Accelerate library and run fine-tuning, but the training speed is quite slow, since only one GPU is working at any time. Therefore, we later used the LoRa approach to reduce the GPU memory needed for fine-tuning. This method greatly reduced the cost of model fine-tuning and also yielded good experimental results. For the first task, we used the most frequently occurring answer as the label. The input for the model is the question-answer pair, together with the image, and the model is trained as a sequence generation task. We tried a total of 4 different pre-trained models, which were BIP2 OPT 2.7b. BIP2 OPT 6.7b, BIP2 OPT 2.7b, COCO. This table shows the scores of the best individual model we trained. In our preliminary experiments, we found that the BIP2 model with OPT as text encoder usually performs better than T5. The BIP2 model with 6.7 billion parameters has a higher score on our validation set, while on test set, BIP2 2.7b performs better. For the second task, we modifying the input prompt as shown in the example and setting the labels as unanswerable and answerable. However, during tokenization, these 2 words were split into tokens of different lengths. To address this, we came up with the idea of replacing the above 2 words with yes and no. This approach allowed us to calculate the score using the probability of a single token, ultimately increasing the average precision to 82.51. In the end, we trained 20 models under different hyperparameter and random seed conditions, and generated the final answer by taking the average of the predictions from each model through an equal weight voting scheme. Thank you for watching.